Good morning, Geodians. This is Mike Horton, project creator of the Geonet network, and today I have with me Claire Liu, co-founder and director of PolyExplore. Welcome, Claire.
Thank you, Mike. Thank you for having me. I'm excited to be here.
Yeah, it's going to be fun. So tell us a little bit about yourself and how you got into the crazy field of GNSS.
Sure. I'm Claire Liu. I'm the co-founder and director of business development and marketing at PolyExplore. After graduating from university, I got my first job at Novotel. And that's how I got introduced to the GNSS world. And I find it fascinating because it has such a long history in technology and it's very complex. But it's actually a technology that we use day to day without maybe realizing it. So I find it's exciting. Ever since I just stayed in this crazy GNSS world to now.
Super, super. What did you get your degree in at the University of Calgary?
I actually got it in electrical and computer engineering, but I somehow got into geomatics in my career afterwards.
Yeah. And what did you first do at Novotel?
I was the verification engineer for their measurement engine.
Super. And how did you learn about PolyExplore?
I feel like it's a transition as I move in my career. So from Novotel, it was mainly focused on GNSS and then a bit of the inertial navigation system. Mm-hmm. After that, I went to some startups focusing on inertial measurement unit. But with Poly, it is a technology company that integrates all the technologies aforementioned. So they don't just do GPS IMU, they also add LiDAR and camera and antennas to a full solution of navigation and mapping.
Super. Well, let's talk about Poly. So Poly, we got all the cool Poly products here to talk about. This is going to be super fun. Why don't we start with the basics and work up to these bigger, more sophisticated units. So let's talk about what the Poly units do.
Okay, so let's start with the inertial navigation systems. To be more exact, this is what it looks like. It has the GPS and IMU component inside with the motherboards, with all the other processing units and all the other cool electronic components. What you can do with this is you can either integrate it in your system, or you can take out the box and then integrate the OEM in your design from the beginning.
Gotcha.
And this will provide you an absolute position anywhere on Earth. And with Geonet RTK network, it can provide you an accurate position down to the centimeter level.
Right.
So this is the first generation. And now this is the next generation. So this, you can tell from the design, from the first generation to the next generation, the design is more ruggedized for tough conditions and environments. And we have different versions as well. This is meant for surveying, construction, or autonomous driving, more tough conditions. And this one is more for automotive market.
Right.
For
volume.
It's
got the classic automotive connectors. What are these called? The FACRA?
Oh, yeah. Yeah.
And then the classic automotive, classic automotive connectors.
So this is for volume applications.
Right.
And this will be for high precision applications.
Gotcha.
Yeah.
And what are people in automotive, why do they need high precision GNSS plus IMU? What's driving that trend in the automotive market to put these more sophisticated, boxes into vehicles?
I'm guessing here. I feel like maybe for automotive, the lane level accuracy is what they're targeting at, but but they do want reliability. Mm-hmm. So they do need like a ruggedized design for the hardware
right.
and also a global coverage for
right.
the RTK network.
For the RTK network, yeah.
Yeah, but for the traditional high precision applications such as surveying or precision farming or smart mining, they will need centimeter level accuracy.
Right.
For example, farming, they only have maybe like a spacing of 20 or half a meter or to a meter
right.
spacing between the crops.
Right.
And as the crops grow, the spacing in between will get less and less.
Mm-hmm.
So they definitely need precision to drive the vehicle autonomously in between the crops.
Right.
Yeah, so
your team has put a lot of work into the sensor fusion algorithms. And what do you think stands out in PolyExplore's sensor fusion capabilities?
Good question. I think that'll naturally maybe move to the mobile mapping system, the big guy here.
Yeah.
The reason is because we started with inertial navigation system. It's integration of GPS MU only, but now we added more sensors, which is LiDAR, this guy here, and also the panoramic camera and the front view camera and GNSS antennas. So to me, the GPS MU, they provide an absolute position. But in a lot of applications, they also need the relative position offered by the LiDAR and cameras. But now we have all of them. So in a way, we are providing an end-to-end solution
right.
for our users.
Right.
Yeah.
In the mobile mapping system, who do you think you sort of compete with in the mobile mapping space?
We're hoping that we're not competing with anybody. That's why we came up with the design
gotcha.
and the price. The traditional, I would say, big guys in this field are Trimble, Aplanix, and Leica, Pegasus. Those are well-known names, but they're quite expensive.
Yeah, give our audience a little bit of a feel for when we talk about a Leica Pegasus system or a Trimble Aplanix mobile mapping system. Like when you say expensive, how much are we talking about?
From what I heard, it could range from like $500,000 to $1 million or even more.
Yeah.
US dollars.
Yeah, the number I always hear thrown around at the shows is about $500,000. So it's quite expensive, those mobile mapping systems. And this is a really, I think, interesting integration of technologies that can do really the full job, full quality.
Exactly. And the cost of the system is less than 1/10 of those well-known names.
And what applications that you guys have, I know, worked on a lot of mobile mapping projects in the past. What are some of the things what are some of the areas where people are doing the mobile mapping?
I would say a lot of them, they want to do the feature extraction, which means like the road asset feature extraction, and also the HD mapping. Mm-hmm. So the feature extraction is mostly about the fixed physical infrastructure on the road that
right.
you see. So you can mount this guy on top of your vehicle. As you drive, you're scanning everything in your surroundings, including the trees, the traffic signs, the lane markings, the buildings, like anything in view. And with the GPS inside, you will know where those assets are. And with the LiDAR and images, you see in details about those objects. And later on with our software, you can extract any objects or any assets in any standard or customized formats you want. And another application is the HD mapping. So that's, other than the objects, you're basically mapping like everything, right?
Right.
And it's just a matter of maybe the formats and information in the export map product.
Right.
So we can export to OpenDrive, GeoJSON, and Lamelight 2, Protobuf, like a lot of the industry standard formats or any customized formats. Eventually, the HD mapping is to support the autonomous driving.
Autonomous driving.
Yeah.
How do you feel about the autonomous driving market? How do you feel it's coming along?
I feel like I want to discuss this with you. I feel like when people talk about autonomous driving, maybe people think about the cars on the street. But to me, I feel like it's more than that. It's not just the cars on the street, but it could also be like the tractors on the crop field, or the heavy machines, or the big mining trucks on the mining field.
Yeah, I think it is pretty diverse. I think it's generally just autonomy, right?
Yeah, yeah.
It's not just autonomous cars.
Exactly.
Very cool.
I feel like for autonomous driving, it really depends on the detailed breakdown of the field. For automotive, I think it's a very difficult field to get in for startups, because you will need the production and also those regulations to be certified and comply with.
Right.
But for precision agriculture or the mining industry, I think that's where we could shine.
Makes sense. Well, let's talk about this box. This one really fascinates me. So this is sort of like a supercomputer for your car. And why don't you tell us a little bit about what all it's got inside?
Sure. It has GPS MU inside.
Right.
And also it has GPU inside.
Right.
So in terms of the processing power, with the GPU and the CPU, it's like at the next level.
Right.
That's why it can handle all those external sensors if the user wants.
Right.
For example, camera, LiDAR, antennas, and you can also connect to any your portable devices like display, Ethernet, and this CAN or odometer, DMI, you name it.
Right. So this is sort of like on-vehicle sensors.
Yes.
You got your cameras coming in here.
Yeah.
You can connect up your LiDAR here or here through the gigabit Ethernet. Got a full GPU inside.
Yes.
This thing is really a full tilt sort of Tesla self-driving supercomputer system in a box that anyone can buy to do development on autonomous systems, which I think is really enabling.
Thank you. That's the idea behind it. So you don't have to build your own. It already exists.
It exists, ready to go.
You can just plug and play.
Well, Claire, why don't we talk a little bit about GeoDNet? And I know you have some questions on that, so let's talk about GeoDNet.
I would love to. So I find the business model and the movement behind Geonet fascinating. But could you maybe explain a bit more to me and also to the audience? I keep hearing the term DePIN.
Right.
What does it stand for, and what is that?
So DePIN is a term kind of invented in the Web3 land to describe projects that collect data or build out infrastructure and then make that infrastructure sort of available to use publicly. So it literally stands for decentralized physical infrastructure network. And decentralized means that anybody can contribute. People can purchase hardware or in some cases set up open source hardware, whatever it may be. There's many different projects, but anyone can contribute. And then physical infrastructure means you're actually building a real network, whether it's an RTK network like GeoDNet or a wireless network like Helium, collecting car data like HiveMapper and Demo and other projects. So there's just a wide variety of these networks that exist, and the network piece is that you have many contributors doing it. So in the case of GeoDNet, we have now over 15,000 registered stations, which makes it the largest RTK network in the world. And the DePIN strive to build these networks very efficiently, which then passes on savings to folks like yourself and to your customers.
Yes. I see the Geonet coverage map on your website. The global coverage is great, and it still seems like expanding.
It's growing all the time.
Yeah, and I think you have the heavy coverage on US, like
Europe,
India,
starting to get good coverage in South America. I think for your marketplace, it'd be interesting to understand where you have the most users and where you're going to be using GeoDNet the most.
I see. For us, we would see Germany, we would see maybe Switzerland, maybe Belgium, but Belgium is where Substantial is.
Yeah.
Yeah.
But they don't have an RTK network.
Yes.
They're a partner of ours.
I know. They're agnostic.
Yes.
But I think Europe is a great coverage.
It was a great coverage,
Yeah.
I think we do see just a tremendous amount of activity in Europe. And I know they're also very into this whole road asset management, and that marketplace seems to be doing very well in Europe. So I think that's a good fit.
Awesome.
What other areas do you see PolyExplore expanding into?
I think what I see is the drone industry and also the robot industry are gonna grow like tremendously.
Right.
In the next decade or so. And every drone actually needs a GPS and IMU.
Right.
And when they need GPS, they will need RTK.
Yep.
And so I think hopefully we can get into this drone industry and UAV and the robotics.
Sounds good. I know you had some questions on our tokenomics.
Yeah, I was gonna ask. So what is this business model that Geonet uses, and what is tokenomics?
So tokenomics is kind of I think the word to describe these DePIN business models, and it's the idea that you need a system to kind of connect the supply and the demand and make sure that the supply and the demand stay in balance, because that is what affects kind of the token value, and also how to transfer the value from people like yourselves and your customers that use GEODNET back to the token. So in our case, we have a tokenomics where the people who set up the RTK base stations, they earn tokens and in effect create tokens or mint tokens or emit tokens, and people use all different words for it, but emit is the most technically correct word. It emits tokens to the host of the RTK stations, and in effect they're able to earn. And then when customers like yourselves pay us for subscriptions, you're buying back tokens and burning them. And so that allows the revenue to flow from the subscribers of the service back to the token.
So when they buy the RTK device, and from the moment they turn it on, that's when they get the token.
That's when tokens start getting burned. When the host, or maybe you're asking when the host gets the station and sets it up on the roof.
Oh, yes.
Yeah, in that case, that's when they get the token. And when a person turns on a Poly device that's got a subscription that's been paid for, or you sold a device with a preset subscription on it, that's the moment that the token gets burned, gets removed. So you have things emitting tokens, you have things consuming tokens. And we've set it up now with a lot of device manufacturers where sort of subscriptions are included. So when that device is sold, then those tokens get bought back and burned. And that's very convenient because the customer buys the device, and they already have the RTK ready to go.
Yes.
And they can just turn on and go.
Yes, a seamless.
It's a seamless experience.
Yeah.
Because we find, and I'm sure you've found it before too, before working with GeoNet, that setting up and configuring RTK networks is very complicated, actually.
We heard it from our users as well. Yeah.
Sometimes it works, sometimes it doesn't work. Which network do I get on? What's the mount point, this and that? So the standardization of GeoNet makes it much easier for a device manufacturer like yourself to just sort of set and forget. And with the global coverage, you don't really have to think about, if I sell it here, is it going to work? If I sell it there, is it going to work? With few exceptions, GeoNet just works everywhere.
Yeah, even in the remote area, because I see your coverage map.
Yeah, it's grow. I mean, we've focused a lot on remote area to support the farming, and also to support some of our data customers that do other things with the data for like orbit determination, all these fancy geomatic things, right? So you need stations kind of everywhere for some of that stuff.
Yeah.
But the coverage is really growing, and we find that when there is a coverage gap, which is rare, we can usually get it filled for customers. So I think if you find some territory that you need more stations, then you just let us know, and we'll work with the community, and we'll get it covered.
Awesome. And I know that for our, for sensor fusion systems, most of the time, well, it depends on the applications, guys. We want real-time RTK or post-time or post-processed RTK, which is PPK. What about Geonet?
We support both. So we have the solution you guys have been using so far is RTK. But if it comes a time when you want to do PPK, we have a full API for PPK. We save all of their Rhinix data, so it's available for customers for post-processing.
Awesome.
But I think as RTK gets easier, more and more people will choose to go the RTK route. I think PPK, a lot of the popularity of that evolved when RTK networks were really difficult and unreliable. So it was just a barrier to go out, and it was easier to deal with that when you got back to the office, right?
I see.
But if the RTK is reliable and works, it simplifies your life to just do it in real time.
That would always be their first option if RTK
so
is
it's just
very
ready,
accessible.
available, and the networks are there. That's really
That's what you're trying
that's
to.
what we're doing.
Yes,
Indeed.
yes, awesome. How do your users get rewarded, and how do you motivate them to?
Well, we motivate them by finding customers like you who bring in revenue, and that helps build the network and build the token value. We also, we have a pretty clean system where you can just look and figure out, hey, is this an area that doesn't have a station? And if it is, then if I put a station there, I can earn. So it's pretty simple, I think, relative to some of the other DePIN projects that are out there. They're kind of complicated to figure out whether it's going to work for you or not. It's pretty simple for Geonet. Do I own a home? Do I have internet? And am I in a spot, or do I have a friend who owns a home that has internet, and am I in a spot that needs coverage? And if you answer yes to all of those, you can set up a Geonet station. It's pretty straightforward.
So in some of our user cases, they may need to drive like 3 hours long to get the data. In that 3 hours, they may across, let's say, half a city.
Yep.
Or half maybe.
This is your customers.
Yeah.
That do a 3-hour drive.
Yeah. So in that 3-hour drive, they're
using a bunch of different stations. That all is taken care of automatically. So with Geonet, you don't need to think about which station to connect to. It handles all that automatically. Yeah.
Awesome. Yeah, we didn't hear our customers complaining about RTK.
It just works. Yeah. And we're excited to continue our collaboration, Claire.
Yes, me too.
All right. Well, thanks so much for coming in and talking to us about PolyExplore's innovative products in GPS INS and in digital mapping, and look forward to the collaboration.
Thank you for having me here. Happy navigation.
Happy navigation.
Geonet. Mind the sky.